Okay, here we go, lesson 6. So I filmed this on October 11th, 2023. So lesson 6 is all about side angle, side triangle congruence. So side angle, side. That's what we're going to learn about in lesson 6. Let's use definitions and theorems to figure out what must be true about shapes without having to measure all parts of the shapes. Okay, 6.1, information overload. Highlight, we're going to code each piece of given information that is used in the proof. Here's the givens. So I need you to code each piece of given information that's used in this 9-step proof. So there's 1 through 5, and then 6 through 9 are on the other page. So what I'm going to do is I like to use a little bit of color. So we're going to say 1, 2, 3. Those are the sides. 4, 5, 6 are the angles. So they give you that AB congruent to DE, 1 mark. AC congruent to DF. BC congruent to EF, 3 marks. They give you that angle A, 1 mark, congruent to angle D, 1 mark. Angle B, 2 marks, congruent to angle E, 2 marks. And angle C, 1, 2, 3, congruent to angle F, 1, 2, 3. All right, so they give you 4 pieces of information. That's a lot. Here's your proof. We just have to code 1, 2, 3, 4, 5, 6 anytime you see where that piece of information is used. So segments AB and DE are the same length, so they are congruent. Timeout. I see one. AB, DE, that's 1. Therefore, there is a rigid motion that takes AB to DE. Okay, yeah, there is. A to D, rotate B to E. Apply that rigid motion to triangle ABC. The image of A will coincide with D. Whoa. A and D. That's 4. And the image of B will coincide with E. So angle B congruent to E. That is number 5. Talking about angles. We cannot be sure that the image of C coincides with F just yet. If necessary, reflect the image of triangle ABC across DE. I'm going to go get patty paper and show you this. What they're talking about here, so we go step by step. Don't lose people. A, B, C. I always recommend that you also capture all the labels whenever you trace. So there's ABC. Okay, so we went A to D, so we're there, and then you rotate until B and E line up, okay? So we can't be sure that C lines up with F just yet. If necessary, reflect the image of triangle ABC, which is right here. This is the image of triangle ABC. Across DE, there's DE. We got to reflect over that line to be sure that the image of C, which we will call C prime, is on the same side of DE as F. So if we reflect this, we know C is going to be on this side. That's what they're saying. It doesn't change the image of A or B because they are aligned already with D and E. Okay, so we're going to flip. You can see C goes to F. I shouldn't say flip, that was a reflection. But anyway, let's start identifying what we're talking about. So C and F, this is 6 for sure. Now we know the image of angle A is congruent to angle D. That is 4. Because rigid motions don't change the size of angles. Okay? It's true. C prime must be on ray DF since both C prime and F are on the same side of DE. Yep, C prime and F, same side of DE. And C prime is going to be on DF. And they make the same angle with it at D. So what they're saying is that the angle from DF with D, this angle right here, is the same. That's A and D. So let's talk about that. Angle A and D, that's 4. Still. Okay, now let's move on. Now you can see kind of both here. I hope. For the most part. Now segment DC prime. Let's think about what that is. So we're here. There's C. D. C prime. Is the image of AC. There's AC. So D, C prime, image of AC. Well, that's going to be back to number 2. Because AC is congruent to DF. But they're calling it DC prime. Okay? So they must, segment DC prime must have the same length as the image of AC. Okay? We also know that AC has the same length as DF. Okay, there it is again, 2. So DC prime and DF must be the same length. Yep. Since C prime and F are the same distance along the same ray from D, they have to be in the same place. So C prime and F are the same distance from D. 2 hash marks. There's D. DF is this distance. DC prime is also that distance. 2, 2. So I'm going to say AC and DF again. That's 2. Now we have shown that a rigid motion takes A to D. That's saying number 4. B to E. That's number 5. and C to F, it's number 6. Therefore, triangle ABC is congruent to triangle DEF. So, because we've shown this rigid motion, we're going to go A to D, rotate via center D until B aligns with E, reflect over DE. Everything lines up, everything aligns because all the angles are the same and all the lengths of the sides are the same. Okay, long problem. All right, let's go to 6.2. I've got 11 minutes. So 2 triangles, okay, 2 triangles, that's what we're dealing with. Gotcha. Have 2 pairs of corresponding sides congruent. I've laid them out here for us. And the corresponding angles between those sides are congruent. So here's our angle. We're just going to use 60. How do you do that? Well, you line this up and you mark 60 and then you connect the dot. There's my dot for 60. We got a 60-degree angle. Okay. Sketch 2 triangles that fit this description and label them LMN and PQR. Okay. So, segment LM, I decided 3 centimeters, is congruent to PQ. So 3 and 3. I just decided to use 3 and 2. You'll see why in a second. Segment LN, congruent to PR. So these I made 2 centimeters. That way we have 2 pairs of congruent sides. Then angle L is congruent to angle P. So I just made angle P and L 60 degrees. So P and L are going to be 60. Now, we got to make 2 triangles. So what I did down here is I set up PQ 3 centimeters. LM 3 centimeters. I made a 60-degree angle coming off of P and coming off of L. So how did I do that? Well, I just used the protractor, lined everything up, found my 60 and made the connection. But I only made this side length 2 centimeters. So you'll see my little dot over here. I did it again, made it 2 centimeters. Okay? Because PR and LN need to be the same distance. All right, so here we go. In both instances, you've got a 3, a 2, and a 60-degree angle, which I just created myself. A 3 and a 2 and a 60-degree angle. So there's only one way to draw these 2 triangles, and you got to connect the dots. Okay, so we've got 2 triangles. Use a sequence of rigid motions to take LMN onto PQR. So we're starting here. This is the pre-image. So the start or the original. And this is going to be the image, which is going to be the copy. So, what do I need to do? Well, start with your points. Got L, M, N, 2, 3, 60. Thanks. Somebody's knocking at my door, but I am filming. Can't be disturbed. I only have 5 minutes too. Oh no. Alright, so what are the motions from LMN to PQR? That's the question. Let me just finish this real quick. Alright, so we gotta go from LMN to PQR. Well, I know L and P are gonna align. So my first step, I always like to translate points that I know. I usually start with the first letter. So let's go translate L to P. You could have also called it directed line segment, LP. So L to P, we're gonna go there to there. Okay, I usually like to rotate next. So rotate. Let's see what it is. Rotate clockwise until M and Q line up. Or align is a better word. So rotate clockwise. Center P. Degrees are gonna be, let's find out. Degrees are gonna be N prime, hang on. It's gonna be MPQ, because that's how far I gotta get. So M prime PQ. So angle M prime PQ, and that'll get us there. That's it. 1 and 2. 1 and 2, we're done. Easy peasy. All right, now what you're gonna find out is all you need is 2 sides and the angle in between them to prove side angle side. Number 3, Mai and Karan want to prove that in an isosceles triangle, that's an isosceles triangle, the 2 base angles are congruent. So the goal is that we prove that angle PAB, this one, is congruent to angle PBA. This is our goal. Okay. Finish the proof they started. Draw the auxiliary line and define it so that you can use the side angle side triangle congruence theorem. So I see what they're saying here. We got to prove these 2 angles are congruent. We already know these 2 sides are congruent. Now, you've got this angle that I'm going to color in right here. So that way we know it's a little bit different. So this green angle right here. Now, if I were to draw the angle bisector of APB, so say I just drew the angle bisector, split this angle in half. If I drew the angle bisector, it would look something like this. So say this green line equals the angle bisector of angle APB. APB. So I just drew an auxiliary line right here. Is an additional line you can draw. It's pretty cool. And I got to define it. It's the angle bisector of APB. So draw the angle bisector of angle APB. Segment PA is congruent to PB because of the definition of isosceles triangles. That's what an isosceles triangle is. Angle BP, let's call this Q. Why? Because Q is a weird letter and I feel like it. So angle BPQ is congruent to angle APQ because PQ bisects angle APB. PQ bisects angle APB. So therefore, this is congruent to this. Segment PQ is congruent to itself. That means that both triangles share PQ. So it's congruent to itself. That means that PQ is the same for triangle PQB, and PQ is the same for PQA. So therefore, triangle APQ, this one, is congruent to BPQ by the side angle side triangle congruence theorem. That means that we have a side, and the angle in between them. That is known as side angle side. That proves two triangles are congruent. Therefore, angle PBQ congruent to angle PAQ. All right, there's my bell. I gotta go. Barely got it in time.